Hello everyone, I'm Xinqing from Institute of Computing Technology, Chinese Academy of Sciences. I'd like to present this research titled Cross-Dataset Activity Recognition via Adaptive Spatial-Temporal Transfer Learning. This work is jointly done by Xinqing, Yiqiang, Chen, Jindong, Wang, and Chaohui. Human activity recognition aims at recognizing activities by training models on the large quantity of sensor data. Since it is difficult to acquire abundant labeled data, it is necessary to utilize the labeled dataset to help annotate the unlabeled one. We often refer to it as Cross-Dataset HAR. However, data from different datasets really follows different distributions. Directly training model on the labeled data may result in poor performance. So, how to build well-performed model for cross-dataset HAR? Transfer learning is an effective paradigm for solving this problem. What to transfer and how to transfer are two key points. For what to transfer, although several methods tried the source domain selection, most of them work in deep neural networks, which are computationally constrained. As for how to transfer, existing work fails to consider the temporal relationship between features, which may result in negative transfer. First, to solve what to transfer problem, we show the spatially adaptive feature learning. We adopt the idea of adaptive distribution factor from an existing work. We treat the divergence of marginal and conditional distributions as the global distance and local distance, and dynamically evaluate their importance. Different from the existing work using a distance, which need to build a binary classifier, we use MMD as basic distance metric to estimate mu. By calculating the overall distance, we can achieve source domain selection. As for how to transfer, we learn both spatial and temporal features. We focus on the temporal feature learning by extending the work of geodesic flow kernel. In general, GFK learns the transferable features gradually by integrating an indefinite number of subspaces between two domains, and gradually transfers the source domain to the subspace of the target domain. Along with this process, the features are more likely to be in the target subspace. However, GFK treats all temporal factors as equally important. Taking inspiration from Markov property, we believe the latter transfer has better influence. Thus, we extend GFK with the temporal factor to weight the importance of transformation. Adaptively combine the two main learning components we call the proposed approach ASTTL. It learns the transfer prediction function for cross-dataset HAR. We make some pre-process and simulation experiments on 4 public HAR datasets. We construct cross-dataset scenarios by taking these datasets as target in turn, the other 3 as source candidates, and then build a transfer learning model for the selected tasks. Firstly, we evaluate the performance on source domain selection by calculating the domain distance between the target and each source domain, taking the classification accuracy on the target domain after transfer learning as ground truth for domain similarity. Results of ASTTL are consistent with the ground truth, which is superior to the comparison methods. We evaluate the classification performance by comparing with several methods, and our method achieved the best performance on 4 transfer learning tasks, with an average accuracy improvement of 8.7%. Then, we compare the 4 ASTTL with 2L variations. Results show that both temporal feature and spatial feature learning make an important contribution to the performance. Besides, we make fine-grained evaluation. Results show ASTTL can make good classification on each activity. Sensitivity analysis shows ASTTL is robust in human activity recognition with respect to a large range of parameter choices. ASTTL reaches a steady performance within fewer than 20 iterations. We also analyzed the time complexity in our paper. Furthermore, based on the proposed method, we designed a system to make application in the real environment. It is composed of two components: the software on a smartphone for activity data collection and the software on a server for cross-dataset transfer learning. Evaluation on the lab collected data shows that application achieves satisfying performance in real activity recognition scenarios. The survey on 24 users shows that most of users are satisfied with the system. So to summarize, our main contributions are the following. We present an adaptive spatial-temporal transfer learning approach. It learns the spatially and temporally adaptive transferable features in a uniformed framework, and it can achieve accurate source domain selection and activity transfer in cross-dataset HAR problems. It can be applied in the real-life activity recognition scenarios. For more information, please refer to our paper. Thank you.